when we ask students that, do you like logarithmics in your part 2 O-level paper, you need to select some questions as your preference. So in that cases, most of the students, about 480% of the students are suffering from this logarithmics. You like or not, in two instances, there are two questions. In those two questions, you should definitely face these logarithmics. So the thing is, they cannot understand the basics. That's why they are suffering at that moment. So I'll explain everything in detail. Let's start from the beginning. Okay. That means logarithmic. Um, that means that is also a representation of number. We have the index method, um, and we studied decimal method, fractional method, ratio method. Likewise, logarithmic also a representation of numerical values. For an example, I'll indicate one. Log. Okay, in logarithmic value, we are not going to write the whole word. We are using the representational word as log. Here we have three components. Okay, three important components. The first one would be base. Okay, log a base. Okay, base. This would be the base. The base should be located little below this wording. It should be located little below the wording log. Thereafter, and it should be a little smaller one. Okay, you cannot write log 5 something like that. Okay, you cannot write like that. The perfect orientation of this letter would be little lower. This would be a lowercase letter, so it should be located below this logarithmic word. Thereafter, let's have 25. Okay, 25. That is in the same orientation with log. That's in the same orientation with log. Thereafter, we have an answer. We have an answer. Okay, this is the proper logarithmic notation. In this notation, we have three key things. This log means this is indicating the logarithmic sign. We are dealing with logarithmic. Then the lowercase value. Okay, there's a small value. There's a lowercase value. It will indicate the base. Okay, it will indicate the base. And this should be our answer. There are so many answer, value, finalist. Likewise, there are many terms to indicate this one. Let's use the simple one as answer. This would be the answer, and the number, okay, the number which is equals to this whole logarithmic value. The number, there is a particular single number which is equals to all the logarithmic value. That would be our index. That would be our index. That would be our index. Okay, so what it means? Okay, what it means, the logarithmic, what it means, that means, yeah, the notation, we are going to convert the logarithmic notation. As people, the students who know mathematics, they will understand what is a logarithmic. The people who don't know the logarithmic, they cannot understand. So we have to make it simpler to understandable for everyone. For that, let's convert this to simple. Okay, normal notation. This would be the logarithmic notation. From the logarithmic notation, we are going to convert it to normal notation. So here the base is 5. Base is 5. Index is 2. 5 to the power of 2, which is equals to 25. Which is equals to 25. That's what this logarithmic indicates. That's what the logarithmic indicates. That means 5 to the power of 2, which is equals to 25. We already know this now. We already know this. 5 to the power of 2 means 5 multiplied with 5, which is equals to 25. That's all. This notation of logarithmic indicates just a simple thing. The number, the lowercase value would be our base. The number located right side, which is our index, and the number which is situated near to the logarithmic value, that would be the answer. 5, base 5, index 2, and the answer which is 25. Answer which is 25. So this is the way you should convert a given logarithmic value to simple notation, to the normal notation. Okay, next, let's have something else. Log base b a, which is equals to c. Let's make, okay, we are going to convert the given logarithmic notation to simple notation, okay, normal numerical notation. Let's try to answer to the question. So the answer would be the base. Okay, first of all, we need to denote our base, which is b. B, the index, which is c. B to the power of c, which is equals to a, which is equals to a. That's all for the conversion from index notation to logarithmic notation to index notation. Okay, then one more important thing in this logarithmic notation, when we have, okay, log base 10, okay, not for other bases. When you have log base 10, okay, log the base as 10, in these cases you can denote this log base 10, instead of writing like this, you can denote it as LG. Okay, log base 10, here I'll give you 1000, which is equals to 3, which is equals to 3. We are converting this to our index notation. So instead of this log base 10, we can write it as LG, LG 1000, LG 1000, which is equals to 3. Okay, in some cases you will face something like that. At that time, don't be confused. Without any basis, how can we convert this one to index notation likewise? No, not like that. Here the important thing is, if the base is 10, they will denote. Okay, think like that. This 0 and this 0 cut off. So we have only log. Instead of log, we have LG 1000. LG 1000. Okay, this one was converted as LG. So the notation of this one in index 1, that would be same. The base 10, index 3, which is equals to 1000, which is equals to 1000. So don't bother about these things. When we encounter any questions, okay, any application of these questions, at that time, you will understand how this one came like that. Okay, we will discuss everything in detail. Now you should have an idea. Okay, so when something like that, this would be something like this. Okay, likewise, you should have a basic idea about these things. In questions, let's apply everything accordingly. Okay, now let's do some simplification questions in logarithmics. Okay. I already told you there is a relationship between index and logarithmics. Okay, logarithmic notation can be converted as index notation. Similarly, the index notation, from the index notation also we can convert that from index notation to logarithmic notation. That's the thing we are going to do here. Okay. When I give you an index something like that, 2 to the power of 3, 2 to the power of 3, which is equals to 8. My question is, here there is an index notation. You should convert this index notation to logarithmic notation. How can we do that? So here you should identify the components. This is our base. This is our index or power. This would be the answer. Okay, 2 to the power of 3, the answer would be 8. Okay. Let's convert this to logarithmic notation. So log, let's write log. What would be the base? Base is 2. So 2 here. Answer 8. Okay, 2. Not index should be located separately. Okay, index should be located separately. So here we have log base 2, the answer which is 8, that's equals to the index called 3. Index called 3. Okay, this is the conversion from index notation to logarithmic notation. Same as previous one. The only difference, the positions. Okay, the positions. That's the only difference between these two notations. Okay, in the first case, log base 5, the answer which is 125, that's equals to 3. That's equals to 3. In the last one also, log base 4, the answer which is 256, that's equals to the index 4. Okay, then after the second set of questions, conversion from logarithmic notation to index notation. So here the base is 7. 7 to the power of 2, that's equals to 49. Equals to 49. But here we don't have any base. So I already told you that log base 10, instead of log base 10, we can denote it as LG. 100, that's equals to 2. That means 10 to the power of base 10 to the power of 2, which is equals to 100. Okay, this is the way you should answer to the question.